Hi everyone. I'm going to do a speed through of number 7 of the course reader on page 15. This is my third time making it, so hopefully I won't be going too fast. First time YouTube said it was too long, and the second time I made it, my computer didn't save it because it doesn't like me. So basically what this question says is an enzyme catalyzed reaction was carried out in a solution buffered with 0.06 molar histidine, pH of 6.3. As a result of the reaction, the pH fell to 5.7. Use pKa values alpha COOH equals 1.82. The imidazole, sorry, I'm really bad with pronouncing, I'll just say R group, side chain is 6.0 and the NH2 is 9.17. How much acid moles per liter was produced as a result of the reaction? Okay, so the first thing that we can notice is that we're going to the volume right here that isn't specified. So I'm going to assume that's going to be 1 liter. That way I can convert this to moles, because you always want this in moles. If they don't specify the volume, you can assume 1 liter. That way that's why we can directly sometimes, when they don't specify the volume, that's when we can directly take the molarity and not do any conversions. Anytime they give you something besides 1 liter of volume, always convert this into moles. Like I said, I've already done this a couple times, and to save myself some paper, I'm just going to kind of go through it. So basically what I like to always do first is I like to draw my roadmap of where I'm going. So this is going at 1.82. This is going at 6.0. And this is the R group of histidine, and this is going at 1.97. Now for this particular problem, we don't care about these two groups because they're not going to change relatively. The pH is hovering around 6.0. It's really far away from both of these numbers. So I'm not even going to take into account either of these. Okay. If you want, you can look at the 38A of one of my videos, and this will have a better drawn out roadmap of what I usually do. But for this particular problem, these are the groups that they gave you, and I wanted to keep everything consistent. What I also like to do is I also like to draw out where my pH is relative to my pKa. That way when I'm done and I'm double checking, I know what I'm looking for. So if my pH is greater than my pKa, I'm going to have more of our base form. If it's on this side of the pKa, I'm going to have more of this form than this form. If my pH is on this side of the pKa, then I'm going to have more of this form than this form. That will come into handy a little bit better. This is the actual equation we're going to be using. So the hard thing about this equation, this problem, is it doesn't necessarily, it's hard to start off, because in all the other homework problems we've been given are starting pH, or not starting pH, but are starting concentrations. This one we have to calculate both the start and the finish. So this is why it's very crucial that anytime you do one of these problems, you write out what your starting is and what your finish is, and what you're going to be solving for between the two. What we are solving for is how much of this has been converted into this. Because every molecule of acid that was created by this enzyme is going to take one molecule of this and convert it to this. Vice versa, or not vice versa, but same kind of thing in another way, is every mole of this, every mole of H that was created is going to take 1 mole of this and put it in here. We'll come back to that. So what you do first is I'm going to take this equation down. I'm going to subtract 6 so I can solve for the ratio of base over acid. Subtract 6. I'm going to get 0.3 equals log base. raise 0.3, base 10, raise it to the 0.3. I'm going to get 2 equals base over acid, multiply by the acid to solve for the base. Okay, now our concentrate, or the amount of moles that we have is 0.06, and that's the total amount of moles. So the amount of our acid that we have and the amount of our base are going to equal the total amount of our backbone. This is what I like to call the backbone, because it's not really, it's what you have, different forms of the backbone, but the total is what you have. Alright, so now what we're going to do is we're going to substitute the acid into the base, get 2 acid plus 1 acid equals this, 3 acid, divide by 3, and we get 0.02 moles of acid, and then plug this back into this equation, and we get, if we solve for base, we get 0.04 moles of base. Okay, we're going to come back up here. This is the start. Now we're going to do it for the finish. This is going to be negative 0.3 equals log base over acid. If you take 10 and you raise it to the negative 0.3, we get 0.5 equals base over acid. Multiply by acid, we get 0.5 acid equals base. Now, just like before, the total moles has never changed. The forms that we have do, but we still have base plus acid equals the total amount. Substitute in 0.5 acid plus acid, 1.5 acid. 0.6 divided by 1.5 is going to give us 0.04 acid and 0.02 base. All I did was copy that to the next page. Our start, we have 0.02 acid, and we have 0.04 base. At the finish, we have 0.04 acid and 0.02 base. Let's look at something real quick, just to double check that we're correct. So at the start, I want to have more base than I do acid because my pH is greater than my pKa. At the start, I have 0.04 base and 0.02 acid, so that's correct. At the finish, I have a pH that's lower than my pKa. And this is going to be, and at the finish, I have 0.04 moles of acid and 0.02 moles of base. So our acid is greater than our base. This is something that takes you 30 seconds to do, but I promise you this has saved me many times on tests, and I recommend writing out your start, your finish, and always double checking to make sure that the relative concentrations make sense given your given pH and your pKa. If your pH is below your pKa, make sure that you have more of this form. If your pH is greater than this, your pKa, then make sure you have more of this form. All we have to do to finish this off is find out the difference of how much base did we convert into our acid. So at the beginning we had 0.04 base. Now we have 0.02 base. So we have 0.02. So if we subtract the difference is 0.02 moles per liter, because remember this is all in 1 liter. And that's why I did that. 0.02 moles per liter of H+. So this is how much H+ has been created, because every, let's just say 1 molecule of H+ that's created will turn 1 molecule of base into acid. If we have 30 molecules of H+ created, it's going to turn 30 molecules of base into acid. If we have 0.02 moles of H+ created, it's going to create 0.02 moles from base into our acid form. And that's exactly what happened. That's what we're solving. So the main points to take away from this are going to be, it's going to be to be able to know how that you always, or the main lessons to take away from this is writing out your start and your finish and making sure that the concentrations make sense once you calculate them. Also, part B of this is pretty simple. You've created this much acid, so if your buffer wasn't there, this is how much acid would be, and you take the negative log of this, and your pH for part B, after doing that, is going to be 1.7. So that's going to be the answer for part B. Simply because without a buffer or anything like that, this is how much acid would still be in there. But the reason your pH doesn't change very much is because this buffer absorbs a lot of your acid that's created. Okay, guys, I hope this helped out. I'm really sorry this was such a quick run through, but YouTube is limiting the size of the videos I post, and so hopefully this one won't be rejected and you'll be able to see it.